Now that you have some practice with the one mean z test and the phantoms method, I want to go back and touch on a few things that we covered previously. So that p-value we earlier stated was a probability. And we gave this loose definition that the smaller the p-value, the stronger the evidence against our null hypothesis that's provided by the sample mean or data. So now I want to give you the formal definition for this now that we have a good working understanding of it. So the formal definition of a p-value is it's the probability that we would take a sample and get the sample mean we did, or one more extreme, which means further in the tail, supporting that alternative hypothesis, if the null hypothesis is true. So the p-value is the probability that we would take a sample and get the sample mean we did, or one more extreme if the null hypothesis is true. So the two parts of this that you want to check for, it needs to say something about the null hypothesis being true, and then it needs to say something about more extreme going on there. All right, so let's revisit our basketball example and look at how we would interpret that p-value with this formal definition. So here's how this would go. The probability that I would only get 8 out of 20 or even less, so that was my free throw percentage when you challenged me, was I got 8 out of 20. So the probability that I would only get 8 out of 20 or even less if I'm really a 75% free throw shooter. So I'm going to state if my null hypothesis is true, so if I really am a 75% free throw shooter, that probability is 0.0009. So altogether it reads, the probability that I would get only 8 out of 20 or even less if I truly am a 75% free throw shooter is 0.0009. All right, so I want to revisit our mean wait time for those customer service calls. And your p-value here was 0.032. So what I'd like you to do is to interpret this p-value in context of this problem using that formal definition. So you're going to do this very similarly to how I just set up that basketball one. So go ahead and pause the video and give this a try. All right, so let's take a look at this. So I'm going to say something like the probability that we would get a sample mean of 3.4 minutes or more, since we're talking about these wait time calls being longer. So I would say the probability that we would get a sample mean of 3.4 minutes or more for wait times on phone calls if the true population mean wait time is really 3 minutes is about 3.2%.